Hello, my dear students. Welcome back. Exams are just around the corner, I know, but don't you worry. Today, we are going to make 3D geometry ekdam simple for you. So simple that you love it. And hey, if you find this useful, don't forget to subscribe and share this with your friends. Oh, and tell me in the comments what chapter you want me to do next. Okay, let's dive into this.
You know how you use Google Maps on your phone? That's all 2D geometry. Just two directions, right? But in real life, things are a bit different. Look at this superhero flying around. To find his exact location in the sky, we need a third direction, height. And that's all 3D geometry is. It's just the real world. So here's our roadmap for today. We're going to build all the concepts step by step from the very beginning. By the end, you'll feel like a master of 3D geometry, I promise. Okay, first things first. Let's start with what you already know really well. And then we'll just add one simple new thing to it. On a flat piece of paper in your notebook, any point has an address, right? We call it P of x, y. To bring this into our world, the 3D world, we just add one more piece to the address, a z for the height. That's it. It's that simple. Now let's actually build this 3D world. And for this, do something for me. Just look at the corner of the room you're sitting in right now. See? You have 3 lines there. One line along the floor, let's call that the x-axis. The other line along the floor, let's call that the y-axis. And the line that goes straight up the wall, that's your z-axis. They all meet at right angles, just like in this picture. Now these 3 axes, they form flat surfaces, which we call planes. So your floor is the xy plane, the wall on one side is the yz plane, and the other wall is the zx plane. These 3 planes together create our entire 3D space.
And here's a very important point, especially for your 1-mark questions. These 3 planes divide the space into 8 different parts. 8! And each part is called an octant. You have to remember this word, okay? Octants.
So how do we give a precise address to any point in this big 3D space? How do we say exactly where something is? Now, don't get scared by this big table. It looks complicated, but it's actually a very simple cheat sheet. All it's saying is that the sign, the plus or the minus, of the x, y, and z coordinates tells you exactly which of the 8 octants the point is in.
Let's test this out with a quick exam question, okay? So, in which octant does the point -3, 1, 2 lie? Just look at the signs. X is negative, y is positive, and z is positive. So we have a minus, a plus, and a plus.
If you look at our little table, a minus, plus, plus combination lands you in the second octant. See? Easy peasy. That's 1 mark right there in your pocket.
All right, now for the most important part of this chapter, the formula that is definitely going to come in your exam. This is your new best friend, I'm telling you. So what if we have 2 points just floating in space? Point P over here and point Q over there. How do we measure the straight line distance between them?
And ta-da! Here it is, the hero formula. I know it looks a little long, but just look closely. It's the exact same 2D formula you already know, but with the z part added in. See? It's just an old friend with a small addition.
Okay, enough of theory. Let's use this amazing formula to solve a typical exam question. Tension nahi lene ka. We'll do it step by step together. So here's the question. Are these 3 points, P, Q, and R, collinear? Now, what does this big word collinear mean? It just means, are they all on the same single straight line? How do we check that?
Our game plan is super simple. We use our distance formula 3 times. First, we find the distance PQ. Then, we find the distance QR, and finally, the total distance PR. And if the 2 shorter distances add up to the longest one, then they must be on a straight line. Simple logic, right? Okay, so when we do the calculations, we find that the distance PQ is root 14. Then the distance QR comes out to be 2 root 14. And the total distance from P all the way to R is 3 root 14.
And now for the final check. Does PQ plus QR equal PR? Well, is root 14 plus 2 root 14 equal to 3 root 14? Yes, it is. Absolutely. So the points are collinear. And just like that, you've got a full 3 marks for your exam. Easy, right? That was great work. Before we wrap up, let's just do a super quick revision of everything we learned so it stays fresh in your mind. Just remember these 4 simple things. 1. A point in space has 3 coordinates, x, y, z. 2.
space is divided into 8 octants. 3. The plus or minus sign tells you which octant it's in. And 4. The distance formula is your super tool to solve almost any problem. That's it.
You know, with 3D geometry, you are actually learning the language that describes the entire universe around us. How cool is that? You're learning some really powerful stuff here.
You've mastered this chapter. You can literally find the distance between any 2 points in the universe now. So go into your exam with full confidence. You are going to do great. All the very best from my side. Let me know how it goes.